Hello everyone and welcome to another video from Gamedev. This is going to be the devlog number 5. And in this one I'm going to be explaining how do I generate the world of Isoterra using Perlin noises. So the world that you see right now is generated with Perlin noises, as I said, and I wanted to add a new feature which was caves, which is kind of what you see around here. But when I was doing the implementation, I found out that the result was not what I was expecting it to be. So I went back to the beginning and read the documentation of different tutorials and so on about world generation, and I end up again in the Minecraft world generation wiki, which has a video at the end by Henry Kimber, which explains really in detail how do they do it. So going through that and everything, as I wanted to have a really good world generation, not just with caves, which also with rivers and more, I decided to scrap everything that I had and start from the beginning with following those steps. So everything starts from a flat world. How do we generate this flat world? We basically set a base height to be in a specific number, in this case 10, and then all the blocks will be placed on this base of 10. But this is not that much interesting, so we're going to use Perlin noise. It's a gradient noise with smooth randomness that will output values between 1 and 1, and we will multiply those values by a factor. In this case, we're going to do a 20, and we're going to see that the terrain moves between -20 and +20 of the base value, because we're multiplying the output of the Perlin noise to that multiplier. So this is how that flat terrain looks like with the Perlin noise with a multiplier of 20. We can see that the terrain goes slowly up the hill and slowly down the hill. But we don't want that. We want something normally that it's much more visual and closer. So let's change the scale. The scale basically it's a factor that you are dividing the x and y coordinates that you pass to the Perlin noise generation. Let's change that factor and see how that looks. Now, changing the scale, you can clearly see that the difference is much nicer. We can see these down uphills and downhills much closer, and is much a scale at the actual player. But it's really smooth and really kind of expected how things go up and down. There's no disruption of this Perlin noise generation. So for that, what we do is we use octaves. In this case, this is only using one octave. That's why it's really plain in terms of the generation. But if we use more octaves, then the standard is normally 4. We will see that this changed quite a bit. What's an octave, you say? An octave is basically we calculate another Perlin noise on the same x and y coordinate, but changing a bit the frequency and the amplitude of the noise generation. In the standard is that we double the frequency and half the amplitude on each one of the octaves that we calculate. So let's see how this looks like. Now, changing that to 4 octaves, we can clearly see that that smoothness that we had going uphill and going downhill has totally disappeared. And we can see that the terrain is much more random on the generation, much more unexpected, and actually looks much more natural. So the next thing we're going to do is change the multiplier. This is only have a multiplier of 20, so we are only going from the base height that we set, 20 up or 20 down. So let's change that to 40 and see how this world looks like. Now, changing that to 40 gave us a much nicer generation, which has really huge uphills and downhills. You can see clearly some mountains. The last thing that we could add to make it much nicer to look at is water. So let's add water. So now that we have water, we can see that, well, the water is generated in, and how do we generate the water? We basically said that apart from the base height that we have, that the generation goes, we generate up and we generate down, we also have another level for the water, which is whichever one we want to decide. And we can see the world generation looks much better this way. The next thing we're going to do is working with spline points, which is basically a way of mapping the noise generated from Perlin to a specific height. So let's see how that could look like in graphs. So spline points basically would be defining that at -1 we have this specific height, let's say 10, and for example at 1 we have this other height. This will mean that regardless of the output of the Perlin noise, we will always have the same height. This will generate a flat world from the beginning. But let's see if we do something like from here to here, basically going up from -1 to 1, so from the bottom of the wall to the top of the wall, depending on the Perlin noise. Let's see how this would look like in the map. So basically, this is how it would look like if we use that last spline points definition that we use, going from the bottom of the wall to the top of the wall, increasing the height, depending on the Perlin noise value. We get this. This is basically what we had before, more or less, but instead of using a specific 20 or 40 on the multiplier, we use basically just, at least is what I'm doing right now, we are just using the output of the spline points. I'm using no base height in this case, and this is the generation of the wall. And to be honest, this is already quite good, and it's really simple to implement. But let's change that and let's make it so we can have more abrupt hills instead of just having these ones which are well, still really fluent. Now, to have something much more interesting, let's do it that from -1 to 0, for example, the height does not increase. And then when you start increasing, let's do it that it goes really straight up, close to the height limit, and then a bit more up when it goes to this. So what we will see here is most likely huge plateaus. So let's see. So this is the generation. Basically, as we said, is a huge plateau. This by itself is not that useful, but it showcases how spline points can make the world generation change quite drastically instead of being really smooth. Now, what's next? Well, in Minecraft, instead of using one noise, they use three noises, so I'm going to use the same thing. They use three noises, one which is Continentaless, which defines if a block should be on the water or should be on land. Then another one which is Erorsion, which defines if a block is more eroded or not. And then the other one is Peaks and Valleys, which defines basically if a block should be part of a river, a valley, or a huge mountain. And each one of those has its own specific spline point graph, as the ones that we showed before, but each one is much different than the other. The thing that I didn't find while researching on the documentation and so is how do they merge the output of these three spline points graph together to define the height. That's at least I couldn't find the solution for that. So what I did is basically add them together. So the spline point graph, instead of always being positive values, in some cases there will be negative values. So when the Continentaless is really low, for example in the minus grades, it will be basically minus the maximum height, so basically the bottom of the world. And in this case, what we would see is that it always generates kind of similar to something like this. It will be on the sea. And the same thing for the others. So let's see how this looks like. Now, this world generation looks much nicer. We can see that it's much more fluent between the water level and when it goes high to the mountains. And then also we can see that it's generating a really, really nice shape of reefs here on the coast, like this one. So the next thing that we could do is basically generate the biomes. How do biomes get generated? Same thing, more noise. In this case, we're going to use two different noises, one for the humidity, another one for the temperature. I don't need that much specifically right now because I only have four biomes, which are ocean, mountains, plains, and desert. But if I have them in place already, later on, once I want to add more biomes, which I will already have the base template, so I will only need to map a few things. So let's see how this looks with biomes. And now, well, we have color, which is much nicer to look than just the grays of the stone. So as you can see here, we have different biomes being generated. There's not much difference right now because again, biomes is in the big scale, but you can see the differentiation between the plains, which is basically the green blocks, and what's the coast, which is right now with these reefs. There's not much else to see here, but then the other thing that we're going to generate is 3D noise. Why do we want 3D noise? Because with 2D noise, what we can only do is do this surface, which goes up and down, but we cannot have anything similar to caves or anything similar to arches or something like that. So to have these more interesting textures to the terrain, we have to use 3D noises. In my case, the 3D noise, what I make it do basically is remove blocks. If the 3D noise output is less than 0, then that specific block that I'm sampling will not be rendered to the user. But if it has a value higher than 0, then it will be rendered. But I also want it that if it's higher on the height values, then it's less likely that something is removed. So what I did is use invert lerp, which gives you a value between 0 and 1 on a specific scale, and add this value to the Perlin noise value of the 3D noise. So it's less likely that something gets removed. So let's see how this looks like. Now, let's see if we see any difference at the point. Yes, we can see these kind of lakes being presented. And the best one that I have right now is this one here, which if you follow me on socials, you would have already seen, which is this arch. This here is a naturally generated arc. maybe it's not that clear to see, but if I use one of the internal functions that I have to remove all the blocks and just present the ones on the same level, you can clearly see that this is an arch that is going down the mountain. On the previous examples that I was showing, this was basically a mountain that had water here and here, but now this mountain has this big hole in it that you can basically pass through. You can see here the arc, and I can go through this naturally generated arc, which is really nice. And these are the kind of features that you can only get using 3D noises. So the next thing that is also using, 3D noises is caves. But caves in my examples, it's not that easy. Just because caves in isometric view, they are really hard to traverse. So I'm gonna now remove water, then remove the biomes, so it's easy to see the caves, and also I'm going to remove this 3D noise generation that I just displayed now, so it's easy to see the caves. So now we are back to this gray world with just having the values for the caves. So we can clearly see a cave on here on the right. This is a cave being generated. But the thing with caves is that I didn't invest that much time into implementing them because they are so hard to traverse that basically it made no sense for me to start implementing caves without finding another solution to help the player traverse those caves. Because, for example, this is a generated cave that we have here, but if I fall in it, there will be no way for me to get out in this case because yeah, it's a not that well generated cave, but also there's no ways for the player to actually see where he is. So if we go down here, now what? Where am I? How do I navigate through here? So with the helpers that I have, yes, you can click one of the level view and you will only see the blocks that you have at your level and you will see this, which is, yes, okay, I can traverse this, but how do I go up? How do I go down? It's basically impossible. There's no way for you to know if there's any block that you can jump here. So I can start trying to jump and at some point maybe I will catch something, but yeah, it's not that much useful. So before doing caves, I have to find a way in which you can actually traverse those, because the helpers that I have now are just when you are mining. Yes, if you are mining blocks, then it's really easy to use those helpers that I have to do so. But if you are not mining blocks, then it's really hard to traverse those caves because they are really irregular. So let's go back to the surface. So that will be all for now. This is the current state that I have for the world generation from the one that I had before. I think that is much nicer and much more interesting to actually explore it because you have these mountains, these crevices in it. So that's much interesting. And maybe I'm gonna tweak a bit the implementation just because it doesn't look that it's too much at some point. For example, these 3D noises, as I showed in the top view of the map, is basically like a cheese. So I'm going to change a bit on that, but I'm not going to touch it that much more because I think that the world has to be a scale of the player, and this current player asset is not the one that I'm going to use at the end. So I don't want to invest time into improving this to actually have to change it later on, because modifying all these numbers, modifying all the spline points, modifying the generation of the noises, changing the frequencies, changing the alphas to find something that is quite useful for the use case that I want is, well, it's a tedious job. It's try and error. There's nothing else. I'm just trying an error, generating a view map, and then maybe exploring it as I'm doing right now and see how does it actually look. So yeah, that would be it. If you have any questions, anything, you can ask me in the comments. And yeah, like and subscribe. Thank you very much.